Dina Tri Utari is a lecturer at Department of Statistics, Universitas Islam Indonesia. She is also head Business Industry Social Laboratory Department of Statistics, Universitas Islam Indonesia, and she have many research. One of them is forecasting Indonesian GDP growth using mixed data sampling, regression, and comparison of method for mixed data sampling, regression model to forecast Indonesian GDP using agricultural export. And now I would like to invite Mrs. Dina Tri Utari to presentation and guide practice. We have time about 60 minutes for presentation and 3 minutes for Q&A. So to Mrs. Dina, time is yours.
Okay, thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. May I share my presentation? Okay. In this session, I am going to talk about introduction to interactive data analysis with R Shiny. It is divided into two parts. The first is introduction, which will discuss a brief overview of R Shiny, and then next we will try to build our simple Shiny application. Okay, first, what is R Shiny? Maybe some of you already know about the Shiny. The Shiny is open source web application framework for R. It's developed by RSU Studio. You can host standalone application on a web page or embed them in R Markdown document or build a dashboard. You can also extend your Shiny application with CSS themes, HTML widgets, and JavaScript action. And then Shiny makes it easy to turn analytical analysis into stylish, interactive web application, and presentable to wider audience. There are already a lot of tutorials on how to build Shiny application as an analysis tools. You can visit the website such as shiny.rstudio.com and then show me Shiny and rstudio.github.io/Shiny dashboard. There are several advantages or benefits why we need to use the R Shiny application as our analysis tools. First is diversity. You can communicate results via interactive chart, visualization, text, or tables. And then the Shiny is of use. If you already know about R or you usually use R as your programming language, you can rapidly develop a cool Shiny application. And then the third is shareability. Built-in capabilities let you share your work easily with your colleagues or your friends. And the design of Shiny application is elegant and intuitive. Okay, let's jump to the structure of R Shiny. A Shiny application usually contains two parts. The first is UI. UI is to create user interface. UI used to control widgets that capture user inputs and then display the output and control layout and appearance. As an example, you can manage the title, page layout, text input, and then radio button, or drop-down menu, scripts, and so on. And the second one is server. Server is or consists of set of instructions from user input, like data, and then notation, text, and then process them and produce the required output further displayed by UI script. And then when you build your Shiny application, you need to install the Shiny package in your R or R Studio. and then create user interface or UI file, and create the server file for computation purpose. And you have to name your user interface and and server in the name UI.R and server.R. Okay. And then to run your Shiny application, first you should to open your UI and server file in your R or RStudio, and then you should type run app, opening bracket, closing bracket, or just click the run app button if you use the RStudio. You also can combine your UI and server into one script and name it as app.r or another name. And then to run it, just type Shiny app, opening bracket UI, comma, server, closing bracket. And the next question is, do I always have to open the UI and server file and run it through RStudio? And the answer is no. You can run your Shiny application using a shortcut in this way. First, you should prepare your Shiny application consists of UI and server file, and then make a folder to save your application file. The third is you need to make a run.r file and then find your r.exe location and make .bat file, and then your shortcut has been created. Okay. In the practical session, we will also try to create a shortcut for our Shiny application. The following is an example on how a Shiny application looks like. It consists of header or title panel on the top, and then sidebar panel on the left-hand side, and then main panel on the right. The header panel is your Shiny application title, and the sidebar panel consists user input. And then the main panel display the output that appropriate with the user input in the sidebar panel. To make your Shiny application look more interactive, you also can make Shiny dashboard. And here is an example. This is my dashboard, COVID-19 dashboard that we will try to build in. There are three parts, dashboard header in the top, and then dashboard sidebar and dashboard body. Okay. And then when it comes to sharing Shiny application, you have two basic options. First, share your Shiny application as R script. Yeah, this is the simple ways to share an application, but it works only if user have R script in their own computer. User can use the script to launch the application from their R session. And then Shiny also has pre-built command that make it easy to use file hosted online. The first is run URL. Yeah, run URL will download and launch a Shiny application straight from a web link. And then the second is run GitHub. If you don't have your own web page to host the files, you can host the files for free at www.github.com. And the last is run GIS. If you want to anonymous ways to post your files online, GitHub offers a passport service for sharing files at gis.github.com. And then you don't need to sign up for the GitHub account to use this service. But even you have a GitHub account, GIS can be simple, quick way to share your Shiny project. And then the second one is share your Shiny application as a web page. Yeah. This is definitely the most user-friendly way to share your Shiny application. User can navigate your application through the internet with a web browser, they will find your application up to date and ready to go. And then RStudio offers 3 ways to host your Shiny application as your web page. The first, the easiest way to turn your Shiny application into a web page is to use shinyapps.io, RStudio's hosting service for Shiny application. And then the second is Shiny Server. Nah, Shiny Server is a companion program to Shiny that builds a web server designed to host Shiny application. It is free, open source, and available from GitHub. But if you use Shiny in a for-profit setting, you may want to give yourself the server tools to come with most paid server program. You can use the RStudio Connect. You can visit the website to learn more about how to sharing the Shiny application in this address website. And then, okay, this is our brief overview from me. Okay, let's jump to the practical session. I hope you have downloaded the dataset and installed the required package. Okay, first, you should open your R or RStudios. Okay, I will open the RStudio. Okay. The first, we need to run the old package. Maybe you can follow me step by step for making the dashboard, Shiny dashboard. Okay, you can use the command library Shiny and then library Shiny dashboard. Shiny dashboard, and then the third library tidyverse. Nah, the core of tidyverse includes the package you are like to use in everyday data analysis. One of them is DPLYR package. Now we in the next step we will use the DPLYR package to manipulate or to data manipulation. And then fourth, we use DT, library DT or package DT. DT is an abbreviation of data tables to render the data object in R as an HTML tables. And then the last we need a library plotly. Nah, library or package plotly is an R package for creating interactive web-based graphs. Okay, and then we can run it. You can, oh, sorry. Oh, the data set, the computer will send the data set. Okay. Or maybe you can install the package, the Shiny dashboard that I do first, DT and plotly first. And then we can run it. Okay. And then to load our dataset, I give my dataset or object covina. Yeah. The computer will send the dataset. Oh, okay, wait. I will send you a dataset. Or you can check in your email. They already send the dataset in the email. You can interrupt me when you have error. I hope you can follow step by step. Okay. We can we import or load our dataset with function read.csv, because the dataset in the CSV form, CSV file, and then your working directory or your directory where you save the dataset. I save it in in your working directory. Maybe I save it in COVID-19 application. You can copy your working directory where your dataset is saved. Maybe you can move your dataset and make or move it in one folder. It's up to you, in folder anything. And the name is cosina.csv. This is the dataset about COVID-19 cases in Indonesia. Okay. This is the directory where my dataset saved. And then we use separator, comma, and then we try to load the dataset first, and we can view the dataset, view of INA. Nah, this is, I think it's too small. This is the dataset, consists of 4 columns: death, confirmed, died, and covered cases, COVID-19 cases in Indonesia. Or we can use head of INA to see our 6 dataset, head of dataset. Is there any problem? I hope you can follow me step by step. Okay. Next, as we know before, that the UI, user interface, I am checking the chat column too. Next, okay. And then, as we know before, that UI or user interface consists of 3 parts: header, sidebar, and body. So the first, we will make a header. We use the dashboard header. Dashboard header. And give the header title. Okay. Please interrupt me if you have any problem. Dashboard header, we can give any title. Maybe I give my dashboard header as COVID-19 dashboard or whatever you want. Dashboard header. Okay, and then we create the sidebar with function dashboard sidebar. Check the chat. Will the slide be shared on the? Oh yes. I will share my slide. Oh, you need the slide or the script? Okay. Committee will send the slides and the script maybe if you has any problem. Okay. We create the sidebar, dashboard sidebar with function dashboard sidebar, and then we can enter, and then we add the sidebar menu with ID sidebar menu. You can check the argument that need in the sidebar menu in this help search. Okay. In the help search, you can type sidebar menu to know the argument that need in the sidebar menu. Maybe it's too small. We need the ID and then menu items, and we add the menu items. The menu items. I give the notes here. We will create the first menu item. The menu item is use the menu items, and then I want to show about the sorry, my computer loaded, so I will just it first. Okay. About, and then we need to tab name about, and then the icon. You can also add the icon. You can add the icon, kind of icon. You can see in the help search in the right side. This is the icon. Maybe I will use the icon question circle. This is our first menu item, and then we can add another menu items. We add the second menu items. Second menu items. Second menu items, I want to display my dataset. With the ID data and the tab name also data, and the icon sorry, I use table. And then maybe I want to add plus menu item. I will add the menu item chart. Sorry, chart with tab name chart. And then the icon, we can use icon maybe bar chart. Oh, okay. This is the sidebar menu. We have 3 menu items: about, data, and charts. Okay. Is there any one of you that have or maybe error in your RSU Studio? And then the last, we create our dashboard body. We create the dashboard body with function dashboard body, and we add tab items, type items. We can add the customized tab items to those in the sidebar menu. First, we create tab items for our first menu, about. So we add the tab items with tab name, same as the tab name in the first menu item, about. And then we can also give the appropriate information. Maybe I want to the information. What is COVID-19? What is COVID-19? Nah, H2 is like function to customize your font size. If you use H1 is the biggest font size, and then the H2 is the smaller, H3, H4, and so on. And then you can also give the another information. Maybe I use the H4 or H3. I give the information. What is COVID-19? Maybe we can add the information. COVID-19 is maybe coronavirus disease or COVID-19 is, you can Googling the definition of COVID-19, an infection caused by a newly discovered coronavirus. You can Googling the definition of COVID-19. This is the information to answer the question, what is COVID-19? Okay. This is tab items that inline with the first menu item. In the tab name, in the first tab item, must the same with the tab name in the first menu items in here. Maybe I give the notes tab item for first menu item. The first menu item is talk about what is COVID-19, and we give the information about the COVID-19, maybe the short information. Okay. And then we create the second tab item for second menu item. In the second menu item, we have the tab name as data, so we use the tab item function. Tab name is data. In this tab item, I want to show, I want to display the data set. So we can add first the information about the data. Maybe I add the, this is the data about Indonesian COVID-19. COVID-19 data search from, I get the data from kawalcovid.id. This is the information about the data. And then we display the data with argument or with function dt. We use the dt package. And then we use the function the data table output with the output ID is tab 1, and then we can adjust the height or the width. Maybe the height is auto. This is function to display our dataset in our dashboard. We use a DT package. From DT package, we use the data table output as the function, and the output ID, as you can also check in the help search that they did the data table output. The argument, the tab 1 is the output ID, and then we can set the width, the height, we can set it. Maybe I add the 100%. Okay. And then the last, we add the is there any problem? Or maybe I too quick? Okay, and then the next we create the tab item for the third menu item. In the third menu item, we will display the chart about or from the data. So we add the tab item with tab name, same as in the third new item, chart. Chart, okay, and then we want to create the data summary and some charts. We will present a summary of the data in the box with, maybe I add the fleet row. We want display our summary of the data in a box. The first box, we can use the function value box output. You can check it in the help search here. Value box output. This is need output ID and the width. Okay, the output ID, I want to know the total number of the confirmed cases in Indonesia. So I give the output ID as corn, represent the confirmed cases, and then we set maybe 3, and then the second box, we want to know about the total died cases. So the output ID, I use the die and the weight also 3. And then the next, the recovered cases. Maybe I just write the output ID as REC. And the width is 3. And the last, I want to know the active cases in Indonesia. I use output ID ACT, and the width also 3. Okay. This is the box to display our summary of the data. And then we add some charts. We will create 3 charts, maybe case COVID-19 cases in Indonesia, and then scatter plot of comparison confirmed and died cases, and then active cases growth. So the first box, I give the title maybe COVID-19 cases in Indonesia. And to display our chart or our plot, we use the function plotly output from the package plotly, and then we give the output ID as plot1. We can also set the size. Maybe I set it in equal to 300 and the width maybe 12. Sorry. Okay, this is the first chart. We want to show or display the COVID-19 cases in Indonesia. We use the argument or function plotly output with the output ID as plot1. And then the second, I want to display the scatter plot the scatter plot of comparison confirm and direct cases. In Indonesia, we use the same function as the first chart. We use plot line output, and the output ID is plot2. And then the height is, I set 300. Okay. And then the last chart. I want to display the active cases growth. In Indonesia, almost the same steps in the first and second chart. We use plotline again. Plotline output with the output ID plot3 and the okay. This is the tab item for our third menu item. So please concern in the, maybe you miss the one bracket or comma, the R or R Studio will give you an alert, give you an error if you miss maybe one bracket or comma. Okay. Is everything clear for you? Is everything clear? Okay.
Yes, ma'am, it is clear.
Okay. And then we create our UI with a function dashboard page. Dashboard page consists of header and then sidebar and body. Okay. This is our UI or user interface, maybe script of our dashboard, shiny dashboard. And then we save our script in the name UI.r. You can save it in the same folder when where you save the dataset. You can save it in I already saved my UI script. So you can save the UI script in the same folder with your dataset. And then the next one, we will create the server to calculate the input in the UI. Okay. Have you finished to save your UI script? Okay. The next one, we will create the server. So we add the new script here. Okay. Okay, and we will in the server. We create the server using the function shiny server, server, and then function, and then input and output. Okay, you can save it in the, okay, I also save it in my computer. So I save it in, maybe I need to create new folder, Shiny apps. This is the UI, UI.R, and, oh, sorry. Shiny apps, and then UI.R, and then the second script, I save it server.r. Okay, and then we can run the UIN script server before we calculate to display our chart on our summary of the data. We can run it first. Just click the button run application if you use RSU Studio, or you can type, maybe in here you can type, when you just use R, you can type run app, opening bracket and closing bracket. Okay, I run the server. Nah, the application will appear in the browser. This is our dashboard. Maybe too small. This is our header dashboard, COVID-19 dashboard, and this is the sidebar menu, and this is the body dashboard. But in the data and the chart, because we don't create or calculate the chart or the summary of the data, so it's still empty in here. Oh, stable. Oh, sorry. Oh, yeah, sorry. This is okay. Oh, this is my dashboard. We have the header, dashboard header, COVID-19 dashboard, and then in the left side is the sidebar menu, and in the right is the body. We can see that the about, we already write in the script what is COVID-19. COVID-19 is blah blah blah, and then in the data it is the information. The data is about Indonesian COVID-19 data from kawalcovid.id, and then the chart, we will display the 3 chart: COVID-19 cases in Indonesia, scatter plot, and active cases growth, but still empty because we don't do anything in the server. So back to the server. I will back to the server. Oh, belum kelihatan ya? Oh, udah. Oke. Oh. In the icon about, not display, maybe I question circle. Question circle. Oh, sorry. Oh, circle. We can run it again. This is the dashboard. The icon display on the left of our menu item in the sidebar. Okay, and then we back to the server. Okay. First, we want to display our dataset. So we use this function output dollar. The dollar, because we want to display our dataset, you can check in UI the output ID for the dataset. I back to the UI. In the dataset, to display our table or our dataset, we use the output ID tab 1. So in the server, we write the output dollar tab 1. And then to display it, we use the function render, dt render data table and call our data conf ina. Okay, and then we can check it in our dashboard. We can run app again. Click the run application button again, and then okay. This is the data. The data already displayed in our dashboard body. It's too small, maybe. I don't know. The data consists of four column and 288 rows or entries. The cases occur from 2 March 2020 until 15 December 2020. You can also choose the year you want to show the entries, 10 or 25 or maybe 100. You can choose here. Maybe just 10. We successfully display our dataset in our dashboard. Okay, so back to the server again. Oh, okay. So first we want to display our dataset, so we use this function output $tab1. Tab1 is the output ID that appropriate with our ID in the UI. This is this one, and then we to display the dataset render data table, and we call our dataset save as object of underscores ina, and then we run it again. Run with just click the run application, run app button in your RStudio here, or type run app. Sorry. This is our dashboard. We can check it in the menu data. and the dataset already displayed in our dashboard body. Okay. And then the body is still empty for the chart menu item. So we will display the chart. We can back again on our server script. This is in this. Okay. Can you follow me? Is there any problem, or is there, if you can interrupt me if you face any problem? Okay, then sorry. Kok harusnya nggak bisa nih? Oh, getting an not able to run, getting an error. Oh. Sudah. Can run. Sudah sharing tuh. Oh, can you sharing your screen so I can know your error, Mr. Artimital. Oh, after we create UII server code, so what next we do? What do we run? Okay, in this, I want to show you step by step. So when we create the dashboard body for our data, so we first run the server, and then to display our chart, we can add the or calculate the chart after this. So is there any okay, maybe this is the I jump to my server. This is the function to display our data set, and then the next is the function to display our summary of the data in the in the second column, namely number of confirm. This is, or maybe I run it for you to show the dashboard overall. Sorry. Nah, this is the data and this is the chart. Oh, sorry. Oh, this is the chart. The box above is our summary of the data. The number of confirmed cases in Indonesia is about 6 2009 629,000 cases, and the number of died, and the number of recovered, and the number of active. Oh, your RStudio is error. Okay, and then the first chart. The first chart is the comparison of COVID-19 cases in Indonesia, consists of confirmed with the red line, and the died cases with the black one, and the recover with the green line. The x-axis stands for the date that the cases occurred, and then the y-axis represents the cumulative number of cases. For this one, oh, okay. You can download the full script in the Google Drive that committee already shared. And then the second chart is the scatter plot of comparison confirmed and died cases. This is the scatter plot. Oh, you can also download this chart. Just click in the camera icon. You can download it here and save in your computer. Sorry. Okay. Maybe I stop share and I share again. Okay. And then this is the active cases growth in Indonesia. And maybe I will explain about the code in the R script. So I back to the server script. Okay. Maybe I want to describe or explain about this script or this function. This is to display our box. Our box is a summary of our data, the total number of confirmed cases in Indonesia. This is the output ID for our first box. You can check it in the UI. You can check it in the UI. This is the output ID. So in the server, you just write the output $conf, and then to display the box, the value box, you use the function render value box, and then the value is sum of COVID in a dataset column 2. Column 2 is confirmed cases in Indonesia, and you can add the subtitle, number of confirmed, and the icon. It's up to you. I use the icon arrow up. The same way, you can do it to the second, third, and fourth value box. The second value box is we want to know the total number of died cases in Indonesia. So in this script or in this function, we write the output $die. You can check it again in the UI. Die is for the second box. This is output ID for the second box. And then, sorry. And then we calculate the total of COVID-19 died COVID-19 cases in Indonesia, we can sum the COVID-19, our data set, in from the third column. You can also set your color. I use the teal color in this box, in the dyed box, and then the same ways for the third and fourth box. But in the fourth box, because we don't have the active cases in Indonesia, so we can calculate it with column 2 minus column 3. Column 2 is for the confirmed cases and column 3 is for the dyed cases. So it is the total number of cases in Indonesia. Okay, this is the summary of our data that we displayed into the box, and then to display our chart, we need to add some variables, some new variables or column. So we create the new data set. I name it df_daily from cov_ina dataset. The percent greater than percent is the pipe operator, and to add a new variable or new column, we use the dplyr package from tidyverse package, and then we use the function muted here. Muted, we calculate the active cases equal or from confirmed cases minus dyed cases, and then we also add the new variable confirmed cumulative, and then dyed cumulative and recovered cumulative. So for the plot one here, plot 1 is the output ID for our first plot, and then we use the render plot line, and then we can set our line color. For confirm, I use the green color, and then red color, and recovered green, and dyed black color. And then the data that we want to make the chart, we use the df daily, the new data. So maybe I want to show you our new data set. This is our new data set from the cov_ina dataset before. We add the new column or new variable, active, confirmed cumulative, dyed cumulative, and recovered cumulative here. So totally we have 8 columns in the df daily dataset. And then we set our x-axis. X-axis stands for dead, and the y-axis represent the cumulative confirmed cases. And then we add the name of our chart of our line as confirm, and then the color in this function, the color is equal to confirm color. Confirm color is red, and then in the second line, we want to know about the dyed cases. So for the x-axis, same with the first argument here, and then the y-axis, we use the dyed cumulative here, dyed cumulative variable or column, and then the third is recovered cumulative. So the last is we set the layout. we add the y-axis title and the x-axis title and also the legend. So when we run the application, this is the application. This is the first, in this chart, display our argument in the server. The red line for confirm, the green one for recovered, and the black one for died cases. So this is the result of our chart. And then the y-axis is dead, and the x-axis is dead, and the y-axis present for the cumulative number of cases. Okay. And then I back to the R Studio to explain the next function. This is the function to display our scatter plot. Our scatter plot we can check in the UI. Scatter plot, the output ID is plot 2. So in here we type the output $plot2. We still use the render plot live function, and then the data we use the data daily, the new data set, and then x-axis for confirmed cases and y-axis for dead cases, and then the same way we do for the plot 3. Plot 3 is about the cases growth, active cases growth in Indonesia. So this is the function or the script to make our Shiny dashboard, a simple Shiny dashboard, like this, like this. And then we will make a shortcut for our Shiny dashboard. So when we run the Shiny application, we don't need to open our UII Server script in our Studio. So I will show you the steps. First, in the same folder, where you save the UII server file, you make the file run.r. You can open the notepad and type require Shiny. And then folder address is where you save your UII server file. I save it in C in the folder COVID-19 app. And then type run application, folder address, and launch browse.browser true. This is and then we save it in the COVID-19 application with the name is run.r. Okay, we save it. And then the next one is we find our r.exe location. Sorry. You can go to your computer and the program files and R and then bin, and you can copy the directory, and then back to the notepad, you can paste your directory, program files R, and then bin, and add the r.exe, and then add the cmd batch and run.r. Run.r. And we save it in the same folder. As maybe my application dot .bat must.bat. Okay, and then save. We check in our folder. And then we create our shortcut. We can create our shortcut. Create shortcut, and then we can move it into the desktop. So let's check our shortcut. In the desktop. This is our shortcut, and we can run the application without opening the RStudio. So we can run it. Maybe take some. And it launch in the web browser. It launch in the web browser. This is the, sorry, it's not active. I'll stop sharing. Okay. For the conclusion is there are so many things that can be developed in making our Shiny application. And then you can just Googling in internet, just enter the keyword Shiny. There are a lot of tutorials, or you maybe can visit the website like I explained before. So that's all I can say. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you for Mrs. Dina. Very attracting the presentation. I think it's not too fast for all participants. Maybe any question for the participant? You can chat. You can answer in chat box if the presentation is not clear, or you is too late to make a dashboard from Shiny.
So maybe I want to show you the my very simple application that user can upload their own dataset. In the last application, we define first our dataset, but in this application, the user can upload their own dataset. I will show you a very simple example. Maybe I will show you. Okay. Oh. This is K-mean clustering dashboard. So the user can upload their data, their data set. Maybe I will show you. Maybe I have this data set. Data set about COVID-19 in Indonesia, and we have first column is province in Indonesia, and then second column is total confirmed, total day, and total covered, and this is the summary of each variables. And then to calculate or to know the optimal cluster in this menu items, we use the silhouette methods and WSSS method, and then the gap statistic methods, and then the and because function. So we can conclude that the optimal number of cluster is 5 here. So in the K-mean, we can add our type 5 as the optimal number of case cluster. And then this is the cluster member. Aceh province is in the cluster 2 and the Bali in the cluster 1, and then the Jawa Tengah or Central Java in the cluster 5, and then this is the cluster plot with the distribution of cluster. The most member of the cluster is in the cluster 2 with total 21 member, and the cluster 1 with 9 member, and so on. And then we can also make the cluster profiling. So we can know that the cluster 3 has the highest confirmed died and recovered cases, COVID-19 cases. This is maybe can be more useful for another, because user can upload their own dataset here. Okay, thank you.
Okay, very interesting. If the participant want to make a dashboard in very in the accept method like Cummins or ANOVA, you can try it. You can try at home. The syntax just the same. You must install package, and you make the dashboard and running in UII Server. Okay. Any question from Ms. Lisda Iswari? Is there any restriction to the number of attributes from the upload dataset?
Oh, no, you can set your maybe file size or
from the last application, the comments.
Maybe I show you the UII server. Sorry. UII server output. Okay. I'll share screen. Okay, there is no restriction of the number of attributes from the uploaded dataset. You can also set the maximum request size of your data by add the function here, option shiny.max request size. You can add more than I write in my script. So maybe if you don't add this option, the default of the uploaded data is just maybe only 5 mega. So you need to add this option. So there is no restriction about the number of the uploaded data set.
Okay, thank you, Mrs. Gina. It's clear, Mrs. Lista?
Bu Lista.
From Department of Informatics. Any question again? Maybe 1 minute later. Okay, thank you for your attention, all the participants. Finally, we come to the last session of this workshop. Thank you to Mr. Dina for your presentation. Thank you all the participants. Hopefully, the information we have shared in this session will be useful for all of us. Akhirul kalam, billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. I return to the MC.
Thank you.
Thank you, Mr. Muhammad Muhajir, SSI MSc, and thank you, Dina Tri Utari, SSI MSc, for the information and knowledge, and also the practice in RSINI which have been given to us. May it be useful for us. Next session, again, I would like to remind that the certificate for all participants of this workshop session, can you get after you fill the list of attendance in Google Form. You can get the link of the Google Form in the chat box that have been given by the committee. Thank you. Ladies and gentlemen, for the next session, we have the special workshop by theme fitting distribution with R. The workshop will be delivered by Manjat Samuh, PhD from Department of Applied Mathematics and Physics, Palestine Polytechnic University. The workshop will be assisted by Ahmad Fauzan, SPD, MSc. Please welcome Manjat Samuh, PhD as the speaker and Ahmad Fauzan, SPD, MSc as moderator. To Ahmad Fauzan, the time is yours.
Okay, thanks a lot, Ms. Dia, as Master of Ceremony. Assalamualaikum warahmatullahi wabarakatuh. The Honorable Head of the Statistics Department, Universitas Islam Indonesia, Mr. Edi Widodo. The Honorable Chair of the Statistics and Bioinformatics Research Center, Dr. Rahmatul Fajriyah. And the Honorable Professor Manjat Samuh from Applied Mathematics and Physics Department, Palestine Polytechnic University, Palestine as third speaker from this webinar. And also the honorable participant of the third SBRC webinar series are not only from Indonesia, but also from various countries. If I look at the participant, they are from Palestine and from India and others. Let me introduce myself. I am Ahmad Fauzan from Statistics Department, University Islam Indonesia, and I will grade in the third material from this webinar, approximately 1 hour and from the material, and will continue approximately 30 minutes from our discussion. Okay, all right. Webinar participant, now we will enter into third material. Maybe I will first greet our presenters. Hello, Prof. Samu. Oh, I'm sorry. We wait there from some. Yes. Oh yeah. Okay. All participants, the material will be continue approximately 5 minutes later because the Prof. Samu still prepare the here material and for completely from this webinar. Maybe 5 minutes later. We will have a break and we'll start at 13:55. Okay, before we start, I will greeting Prof. Samu. Hello, Prof. Samu. Oh, still,
Hello,
yes.
Assalamualaikum. Yes.
Waalaikumsalam warahmatullahi wabarakatuh. How are you today, Prof. Samu?
Sorry again.
How are you today?
Yeah, I'm ready now.
Yes, okay. Persiapan. I will read the curriculum vitae before the third material from Prof. Samu. I will share the screen about the curriculum vitae from the Prof. Samu. Okay. This very handsome. Prof. Samu from the Palestine. He is from the Bachelor of Science from Hebron, Palestine Polytechnic University, and he get the Master of Science from Yarmouk University from Jordania, and the last from PhD study from Padova University in the Italy. If we see the curriculum vitae from Prof. Samu, he have a lot of experiences from the grant and then teaching from 22. He was teaching from probability theory and then mathematics statistics and so many material from his teaching from 22. And he is interest for the theory sampling theory, permutation testing, sampling theory, and distribution theory. If we read the journal paper, is so many from 26, if I see, and many experiences from him. Okay, Prof. Samu, we will start the material today about the fitting distribution with R. Maybe 1 hour from the material, and then we continue about discussion 30 minutes. Prof. Samu, the time is for you.
Inshallah. Thank you, brother Ahmed. Let me share my screen. I hope you can see my screen now.
Yes.
Yes,
we can see clearly.
Yeah. First of all, let me thanks you and the organizers, and special thanks also to Dr. Rahmatul Fajriya for inviting me to be one of the speakers for this interesting webinar organized by the Statistics and Bioinformatics Research Centers. And it's really a big honor for me to be one of the speakers. My talk will be about fitting distribution with R. And already, Brother Ahmed, if I pronounce your name is correct, introduced myself. Okay, currently I'm an associate professor of statistics at Palestine Polytechnic University and the head of mathematics and physics department. I worked for 3 years at King Fahd University of Petroleum and Minerals. I am a reviewer for some international journals. You can see also some more information about myself on this page. Let us know each other. This is for small audience. I'm really in. I get used to see a small participant with this kind of workshop, but here we see a big audience, mashallah. Yani. So I skipped. So let me first hear about your expectation from this workshop. Please, just 2 minutes to let me know what do you think or what do you expect from this workshop. Either you write on the chat box or you may open your mic for 2 minutes, let's say. Oh, okay. My own, yes. So what do you expect? I hope you can hear me very well. So what do you expect from this workshop? No idea? Yes? Okay, after this workshop, we determine the distribution for the data at hand by using R. Great.
Okay, all participants, you can answer the expert from this workshop. You can write in the chat box, or you can speak in the Zoom.
Exploratory data analysis, yeah, in some sense. Learning how to fit some distribution with R Studio, great. Okay, so I hope we have some more to know the usage of R to explore the data and the advantage of the distributions. Okay, I hope my presentation will fit, or will, let's say, will meet your expectations. So let's go on with the next slides. This is the table of contents. I'm going to talk about a brief introduction to R, fitting distribution with R, evaluate the quality of fit, and then how to fit my data using a specific distribution that is not built in with R. So you have a new distribution and you want to see whether your data come from this distributions or not. So let's start with a brief introduction to R. I know you had the previous workshop with Dr. Dina about R Shiny, which you had some hard activities, but let's see this section. This section devoted for beginners with R. I think there is someone raise his hand. Let's see if there are some questions, please. So R is a programming language and environment for statistical computing and graphics. It's a free software and has a lot of help available online. You can easily access the packages and you can download the software. I expect you all downloaded R software because we need it. And also you had some activities with the previous workshop in R. This R is quite similar to other programming languages like MATLAB, but you know, MATLAB is not a free software. To install R, you need to go to this link, the website of R. Once you run R, you will get this screen. Here you can write your R code or R script and get the results immediately. You can use R as it is, but for educational purpose and even for my research, I use RStudio instead of R, which is also free, but it is more organized than RStudio. Once you run RStudio, you'll get this screen. You have this screen divided into 4 parts. The first part here, you can write your code. And here you can see the output. Once you run your code, you will get the results here below. On the top right here, you can track your activities. and here you can install packages or view plots, help, or whatever. So RStudio is just more organized than the R. R provides a wide variety of statistical techniques such as classical statistical tests, linear modeling, time series analysis, classification, clustering, and many other things. Let us see some examples how to use R. For example, we can use R for simple calculations like, for example, doing sum, subtraction, or multiplication. You can take log with a specific base. You can have assign a value for variable a, let's say a equal 4, 10 to the power a is 10,000. You can have the trig functions, cosine 2 pi. You can assign a vector of data to a variable x. You can do some simple algebra with the variable, like you multiply a constant scalar with the vector x. You can create a matrix in this way. You have, for example, a matrix for the numbers 1 up to 9. We have 9 numbers, and we need to create a matrix of size, let's say 3 by 3. Here I write a number of row equal 3. So I get a matrix of 3 by 3. If you see here, you have the matrix is created column by column. You see 1, 2, 3. Here we have 1, 2, 3, the first column, and then the second column and the third column. If you need to, if you need the matrix to be row by row, we write this command here, by row equal true. This is just a simple example how to use R for calculations or as a calculator. Here's a second example for how to use R to carry out some basic statistical tests. Like, for example, here we have paired sample t-test. Let's see this example. We have, or we need to check whether drinking coffee affected blood flow, especially during exercise. Here we have data from 8 subjects or 8 participants, and we measure the blood flow before having the coffee or before taking any dose of caffeine, and we measure the blood flow after taking a dose of caffeine. And our main concern here is to check whether drinking coffee affects blood flow. So in this case, we use the t-test. For the first time, you don't know maybe which function I should use in order to use or to test, or let's say to use pair t-test. You simply ask Google how to carry out pair t-test using R. You will get this function t.test. In R, you just simply type a question mark before the function, and you will get the help. Here you see the function t.test with its arguments. Here you have x, y equal null by default. That means you can carry out one sample t-test here. If you plug in x and y, then you are carrying 2 sample t-tests, whether they are dependent or independent. Here you have paired equal false. That means you are doing independent sample t-test, and in this case, you need to assign whether the variances of the 2 samples are equal or not equal. In our case, we have paired samples, so I have to write here paired equal true. You can also assign or choose what is the alternative of your hypothesis, whether it is 2-sided or 1-sided from left or right. For our data here, we have the x and y, the baseline and the one under the treatment, let's say, x and y. So t.test x, y paired equal true. You will get the results like the test statistics, the p-value, confidence interval, and you can draw your conclusion. Another example, how to carry out linear regression with R. Here, I want to predict the weight through the height. So I have a sample of height and weight. Simply, we write LM in R. This function is used to fit linear model. Inside this function, we have the arguments weight. You need to type here the response variable, sim, and here you type the predictor variable height. You may have multiple regression, you just plus, you can add more predictors as you have. You type summary of this model, okay, you will get the basics, let's say descriptives about residuals. You will get here the coefficients. If you ask, if we need to write the model, you have the y-intercept here, you have the slope, you have the standard error, test statistics, and p-value. Here you have r squared, the coefficients of determination, which is 0.95, which is very high, and here you have the coefficients of correlation 0.949. If you write summary of AOV, analysis of variance of your model, you will get the ANOVA table. The ANOVA table, you can get it using this function, and here you can have the sum square regression and sum square error, blah blah blah. Here in this command, you can plot also the scatter plot of your data with the fitted regression line. Here, the fourth example in this part, how to write your own function. There are some ready function in R already built in, like the mean. If you write mean of height, you will get the arithmetic mean. If you write SD of height, you will get the standard deviation of your variable. These functions and many others are already built in R, but sometimes you could have a function which is not available in R, then you need to write your function. Here, I want to show you an example. I want to calculate the mean deviation, okay? So I create this function using the name Monjed. Monjed is a function with two arguments. X is the data points, and A is a constant. Here, this function, I need this function to calculate the mean deviation and then multiply by A. So the mean deviation is the sum of the absolute value of X minus X bar divided by the length of X, and then return the mean deviation multiplied by this constant A. Now I want to call this function for the data height. So I write Monjed of X equal height. You can write X equal height and A equal 3. The order in this, if you don't write X equal, A equal, then the order is important. The first argument here correspond to the first argument here. The second one correspond to the second one. So this is just a simple examples about how to use R for beginners. Let me, as this is a workshop, let me ask you to open your R Studio or R and try to type some simple calculations and create. It is more important to try to create your own function. This is very important for even those people who do research with R. So please, may I give you, let's say, 5 minutes maximum to try to do some calculation, try to create a new function, and let me know if you have any question or if you see any error during your activity. Any questions? I know you had some activities with Dr. Dina. Maybe it was harder than this activity, but again, this is just for beginners. If you want, I can show you some. I can write you a function in. Okay, new screen. Script. Do you see the RStudio Studio now?
Yes, we see, bro.
Okay. So we can create any function you want. For example, let's say we have now somewhere, not Monjed. This is the surname of myself. So this is the name of the function. Okay, somewhere the name of the function. Function is the one that you need in order to create your function. You need to write the arguments that you need to pass to your function. For example, let's say we need to write the exponential function. Okay, f of x equal lambda e to the power minus lambda x. So we have data x and we have parameter, let's say lambda. Okay, enter. You open this sign. Okay, for the parentheses. Here you write, for example, let's say we have func equal x lambda times exponential. You write exponential in this way, exponential. Okay, and inside this parenthesis you write minus lambda times x. You need to type times x, don't write space. Okay, and here return function. That's all. So we have this our own function. You need to run this one. You do the selection and make either you type control enter, or sometimes you see here the run code. This is the icon, this icon to run your code, either line by line, or you do the selection for all. Okay, now function Sammuh is ready. We have here warning message in, what is the warning? I able to time zone. This is not an error. Now you write some more, and now inside the parentheses you pass your data. I don't have data here. Let's say x equal this vector 1 2 3 whatever. Okay, and now you write some more x comma lambda. Let's say lambda equal 2, for example. Error, object lambda not found. Lambda, I mistaken with the type. You see here lambda, it is okay. Here we have an error. Lambda, you see what is where is my mistake? Here the argument is lambda, but inside here I'm typing LMA, so there is a typos here. Again lambda yani once you edit your function, you need to run it again. Now you go back by this arrow. You can use your keyboard, the up arrow. Now enter again, and we have the results now. It's nice to have some error in order to learn. So let me know if you have any problems. If no comments, then we go on. Fine. Okay. The second part of this presentation is how to fit distribution using R. Fitting distribution is the process used to select, or let's say, to choose what is the best distribution that fit our data. You have an experimental data, and you wish to test whether this data come from a specific distribution. It is important to have this distribution to be identified in a good or in, let's say, in a proper way, that because once you know the distribution, you need it for further calculations like probabilities, expectations. For example, if you work in wireless communications, once you have the distribution functions, you can calculate what is called by outage probability, bit error probability, capacities, or whatever. So knowing the distribution function for your data is very important. So how to search, or how to find the best distribution that fits my data, we have 4 steps. The first one, you need to guess what is the distribution that suitable to my data. We will talk about it now. Once you know the distribution, you need to estimate the parameter of that distribution. You need to evaluate the quality of fit, and you need to do some goodness of fit tests, like Kolmogorov test, for example. So guess the distribution. The first step is in fitting distribution is how to choose the best distribution that fit my data by usually we do the first step we do is to draw a histogram or some other graphical techniques, and you need to use your experience with the distribution functions in order to match your empirical distribution function with the theoretical one. Let us consider 2 artificial data sets. The first one comes from a normal distribution with mean 0 and variance 1, and the other one from exponential distribution with rate 1. And let's see what we can do. In R, you generated data. For example, from normal distribution, I have here generated 200 data points from normal distribution with mean 0 and standard deviation 1. Okay, I assume this data, I don't know from which distribution it comes from, and I use this function plot dist. This function is in this library, fit distribution plus. Okay, you need to download this library in order to use this function. A plot distribution, you will get these 2 plots. The first one, the histogram with the empirical density, and on the right here you have the empirical cumulative distribution function. Now you need to use your experience with the distributions, like this data comes from which distribution. You feel this is from a normal distribution, let's say. Okay, normal, but what are the parameters and what are the parameters of distribution? I type the function again, plot dist, but now you see in the previous slide here I use plot distribution, my data only. Okay, but here I'm comparing my data with the normal distribution. So my data, and here the theoretical distribution is normal. The theoretical distribution here is normal. Now we compare the empirical density with the theoretical density here. You see it is very close to the theoretical one, either through the histogram or the QQ plot or the CDF, okay, or PP plot. All of these figures confirm that our data come from normal distribution. It is very close to the normal one. Okay, how to know the parameters? This is the next step later on. Other way to find your candidate distribution is to use Cohen and the Frey graph. Cohen and the Frey graph is based on the skewness and the cortices of the distribution. Here you have the skewness, or in more specifically is the square of the skewness with the cortices. You have some well-known continuous distribution. Here I'm writing discrete equal false. That means these are for continuous distribution. You have, if you write the true, that means you are working with discrete distributions. Here, the theoretical distribution that I have is the normal depicted by star. It is here. The uniform by triangle, it is here. The exponential by this square, it is here, and so on. Again, these triangles, star, plus, whatever, these are based on the skewness and the cortices of the distribution. That means for the, let's say for the exponential, okay, here is the skewness, it is 1 dot, okay. That means, again, this is based on the skewness and the cortices of the exponential distribution. Here you have this shaded area for the beta distribution. Why this is an area and this is a square? It depends on the parameters. Here the skewness and the cortices depends on the parameters of the beta distribution. Here you have line for the gamma and this dotted line for the log normal. Okay, our data is this dot, the solid dot, the blue solid dot is this one, the blue solid dot, which is close to the star. A star is the normal distribution. That means our data comes from, or it is mostly likely come from normal distribution. Okay. This is another example or another data generated from exponential distribution. We have 500 data points, and the second argument here is not written, but it is the default one, which is the rate of the exponential distribution, which is 1 by default. Again, I use the plot distribution in order to get the histogram and the CDF, the empirical CDF of my data. According to our experience, this is logs exponential, gamma, or whatever. Let's compare my empirical distribution with gamma. I want to say it is from gamma with shape parameter 2 and rate parameter 2. Okay, my data is from exponential, but let's say we don't know from which distribution comes from, and we are looking for what is the most candidate for what is the most candidate distribution for my data. You see here the empirical data is, or the empirical density is the one with dotted line, while the theoretical one with the red line. So it's a bit far from the empirical one. So there is a difference. Also, it is more clear from the QQ plot. You see our data does not fit, or let's say it does not come from a gamma distribution. According to Collin and Frey graph, we look at our observation, the blue dot. We see it is here, it is located here. It is within the area of beta, it is closer to the gamma. You see this line for the gamma distribution. Here is the exponential here. So it is close to gamma, but maybe with different parameter than the one that I choose here. Here I said my data come from gamma with shape parameter 2 and rate parameter equal 2, but it is not. Okay, from according to Collin and the Frey graph, we see it is almost gamma. Okay, but what are the parameters? This is the next step. Okay, so what we do. So let me summarize what I have said just for a few minutes ago. I generated 2 artificial data, one from normal and one from exponential, and I tried to search what is the theoretical distribution that fits these data. Once you know the distribution, you need to find the estimates of these, or you need to estimate the parameter of that distribution. In the same library, fit distribution plus, there is a function called fit dist. You give the data and with your candidate distribution. you pass to the fit test 2 arguments, the data and the theoretical distribution. If your data come from exponential distribution, then your parameter for the exponential distribution will be 1.0129 blah blah blah. So the rate parameter here is 1.0, or let's say the estimated parameter for the exponential distribution is 1.01. If it is come from gamma distribution, then your parameter should be the shape parameter 0.92 and the rate parameter 0.93. If you repeat the previous, let's say this step, plot distribution, you write your data here, and the parameter of the gamma you write 0.92, 0.93, you will get the red line. It will be more and more closer to the empirical one. So our data is most likely coming from gamma distribution with these 2 parameters. Let's say, let's us check whether the data come from log normal distribution. If it is from log normal distribution, you know there are 2 parameters, and these are the estimated of these 2 parameters, the mean and the standard deviation. Of course, you know the distribution function for the exponential and for the gamma, and here for the log normal. If you adopt that your data come from exponential, then your PDF looks like this way. You have the exponential distribution is lambda e to the power minus lambda x. If your distribution, if you adopt that your distribution is gamma, then you need to write your PDF in this way. If you adopt the log normal, then you need to write your distribution in this way. Okay, what is the most suitable one? According to the Colin free graph, it is the gamma distribution. We need to test to say that the gamma distribution is the most suitable one, or we need a criteria to say that this is the most suitable one. Here I plot the empirical data, the empirical density, with the 3 proposals of the theoretical distribution, with the 3 proposals. Let us look at the CDF or the QQ plot. Look at the QQ plot. You see the log normal, which is in blue, which is very far away from our expected, or let's say our empirical data, while the exponential, the one in red, or the gamma, the one in green, is closer to our data. So log normal is not a suitable theoretical distribution for my data, so we exclude it from the set of candidates distribution. Okay, again, we need to test now whether my data or our data come from a specific distribution, let's say exponential or gamma. There are some test statistics that can be used, Kolmogorov-Smirnov test, Kramer-von Mises test, Anderson-Darling test. And there are some other criteria, goodness of fit criteria that can be used to evaluate your fit, AIC and BIC, which are well known in the field of statistics. The purpose of these test statistics is to measure the distance between the empirical distribution and the parametric or the theoretical distribution. So the formula, if you look at the formula of each statistics, you see it is the difference between the empirical distribution with the theoretical one. In different way, they are calculating the distance in different ways. So these are the well-known statistics to see how the empirical distribution is far away from the theoretical one. If we have another function that is again included in the fit distribution plus library, which is goodness of fit statistics, GOF stat. In the first argument here, you give the fitted models that you used. We have 3 fitted models. The first one for the exponential, the second one for the gamma, and the third one for the log normal. Here you have the statistics for each method and for each fitted distribution. Let us look at the AIC criteria here for the three proposal distributions, we see the minimum one. Of course, the minimum is the most suitable one. Here we have the gamma. So the gamma, according to the AIC, is the best model that fit our data. But we need a test. We need a test that say, okay, whether data, here we have the Kolmogorov-Smirnov test, ks.test, our data, whether comes from exponential distribution with rate 1.01. We see the p-value here is large, which is not smaller than, let's say, a pre-assigned level of significance alpha. It could be 0.05. So we accept H0. What is H0 here? Again, H0 is that our data come from a specific distribution. Our data come from here, from exponential. We say, yes, we accept this hypothesis. Okay, let's check whether our data come from gamma distribution with shape parameter and rate parameter as they are here. We see the p-value is 0.95, which is very high, higher than the one in the previous one. Again, here we accept H0. If we test or we apply the Kolmogorov-Smirnov test for our data, and considering the theoretical distribution, the log normal one, okay, we see the p-value here is very, very small, which indicates that H naught must be rejected. That means our data does not come from log normal distribution. Before we go to the next section, let us have an activity here. May I ask you to try to generate data from log normal distribution and try to check whether your data fit the log normal distribution and compare it with other distribution. You need to generate data from log normal and then try to check whether data fit this distribution and compare it with other theoretical distribution. Let us do this activity together in order to get benefit from this workshop. If you want, also I can go through with you. So first, let us generate data from log normal distribution. So I say my data that equal R L norm. Okay. If you don't know, for the first time you use, for example, this function, you type here question mark and the function, you will get the help here on the right, left. I need to use, in order to generate data, you need to use this function R, log normal. You give the number of data points that you want, the mean, and the standard deviation. So I need to just write here inside 500 data points. And the other parameters as they are, mean 0 and standard deviation is 1. Enter. Once you do this, of course, we need the library fit distribution plus, fit distribution plus. For the first time, if you use this library, you need to install this package. You need to install this package if this is the first time for you to use fit distribution plus. Once you install it, you call it by library fit distribution plus. As you see here in the slides, we need to use the function plot, where it is, plot dist, okay, and your data. Plot dist, sorry, plot dist. Okay, we run this, and the plot will appear here on the, okay, I run the first one, the second one, it's here, make zoom. Okay, here you have the histogram, okay, and here you have the CDF. in order to have the empirical density curve, you need to write, as in the slides here, demp equal to, sorry, demp equal true. The first letter is enough. Now you have the empirical curve or the empirical density. Okay, let's compare this one with maybe you say it is gamma. Let's say, okay, a plot distribution, data, comma, the theoretical distribution, you see how it is, or you can go to the help. You can go to the help with the parameter. Let's say distribution gamma again as this one. Distribution equal gamma, and you give the parameter as a list. Distribution equal, between double quotation, gamma. Okay, and here you need to pass the parameter, how it is. So you have to write it as it is, para equal list, para equal list of gamma. You have to write the shape equal again, shape equal to, rate equal to. It's now it's upon to your experience with distribution. You have to choose what is the best alpha and beta, let's say, for this distribution. Let's say again shape equal to, sorry, shape equal to, comma, rate equal, let's say 1 this time. Here, if you need the empirical curve, you write demp equal to. You see the data is far away from the theoretical one. So I'm assuming my data come from gamma. This is not correct. As you see from the plots, all plots indicates that your data does not come from the gamma distribution. You may play with the parameters, the shape and rate parameter, in order to see what is the most suitable one. Let's draw colon and fray. Okay, maybe I missed the, okay. Disk distribution, okay. Disk distribution. Disk distribution, my data, comma. In order to, maybe by default, I'm not sure that the default one is the discrete or the continuous. If it is the continuous, you have to write here, you can leave it as it is, but if it is discrete, you have to write it false. Let us check by in the help. You see here, question mark. And the help, discrete equal false. By default is false, and I am doing the one with for the continuous distribution. Okay, that's enough for this disk distribution data. Run. Now we have the column for this graph. Our data is here, far away from exponential, far away from normal. Where is log normal? Log normal is this one. It is closer, it is maybe beta or closer to the gamma distribution. You see, it is closer to the gamma distribution. However, we generated our data from log normal distribution, but it is random, or let's say sample from log normal. But it is this data fits more appropriately to either beta or maybe gamma, but you need to try to search what is the best parameter for the gamma. Let's just try to fit this distribution with beta and with gamma and see what are the most suitable parameter for that. What we do now, we do fit distribution plus fit distribution, fit distribution, fit this, I think, fit this. Let's check again. fit dist, okay, data and the theoretical distribution between double quotation. Fit dist, our data like this, and theoretical distribution between double quotation, let's say gamma, and see what are the parameters we get. We have these two parameters, okay, for the gamma. For the beta, you write here beta, run error in computing default starting values. For we need maybe a starting values for the beta distribution. Not sure why. Okay, maybe we change to let's say exponential. Here we have the rate should be 0.57 and so on. Okay. For the beta, maybe you can look it for later. Maybe you need some starting values for this distribution. Anyway, okay, we got the estimates. Now I need to find the test statistics, goodness of fit test with the EIC and BIC criteria. We write a GOF stat. Let's call the first one by fit1, and the second one by fit2. Run it again in order to store the results in these two variables. Now we need to use ks.test our data and the theoretical distribution with the proposed estimate of the parameters. Okay, so we write here ks.test. Inside we write our data, our fitted models. We are proposing, yes, we have fit1, comma, and here we assign the theoretical distribution, but in this function we write p exponential, the CDF. And the first one, gamma, is gamma. The second one is exponential, p exponential. Now run these two lines, Control Enter, and we get an error. Okay, fit k.sy error and must be. Let's again see the function. Okay, here we need to not try the fitted model. We need to pass our data. Not the fitted model. And also we need to specify the estimated parameters. So again, here we write our data, and here data, okay, gamma, and our shape parameter equal as we got here, which is 1.15 blah blah blah, and the rate parameter equal 0.66. This is for the gamma. For the exponential, we have only the rate parameter equal 0.5. Run it again now, and we don't get an error. Okay. So you see the test statistics and the p-value. Here the p-value is very small. That means our data does not come from gamma distribution with these parameters, and also does not come from exponential. Here we reject is 0. So you need to search again to test with other theoretical distribution. You need to try with beta, but you need to check the error that we got, why we got it. But in order to not lose time, you may think about it later. So this is for fitting distribution for our data. Now, if you don't have any questions, I'm not sure if you are following me. If you have any questions, any comment before I go to the next section? There are something in the chat.
Okay, please, all the participants, if you have any question, you can write in the chat box, or you can speak, feel free to interrupt him. Maybe I have one question, Prof. Samu.
Yes, please.
Does all the data have a distribution? Does all, if we have a data, if the
Yes.
data have a distribution, or maybe if we have the data but there is no distribution that fit to this data?
Yeah. Yes. There are some well-known distribution which are already built in R. You
Yes.
can call them, as we see in the column free graph. There are some well-known distribution, but if your distribution is not the one among the well-known
Yes.
distribution we need, this is our next step, the final section.
Yes. Thank you. And this comment from Rara, if we have data and want to know its distribution, can in R generate distribution recommendation that describe our data?
Yeah, this is what is proposed by this graph, column and the free graph. Okay, this is the proposals that are given. Okay, I mean, if you look at where is it? Okay, here. Here, this plot suggests you some candidate distribution. Your data is here. Again, this graph is according to the skewness and the cortices of the distributions. Once you plug in your data to this function, column and the free graph, it will be inside they will calculate the skewness and cortices and assign it on the plot. Now, according to this plot, you will guess what is the most candidate distribution for your data. So R propose you some distributions according to this proposal, column and the free graph. I hope I answered your question.
Is Rara,
Again, for other distributions that are not built in R, we will talk about it in a few minutes, inshallah.
Okay, Mr. Rara, the answer is complete for you.
Sorry?
Excuse me?
Yes?
Prof?
Yes.
Is there any requirement for an sample size to determine or fit the distribution?
Yeah, since you are looking for the theoretical distribution that fit your data, I think how much it is large, how much is better. This is well known. How much it is large, how much is better. But for some other purposes, like to do per t-test or to do regression or to do whatever, there are some formulas for how to calculate sample size for specific test or for specific purpose, let's say. But for fitting distribution, how much your data is large, how much is better.
Thank you so much, Prof.
Yes. If your sample size is small, that means you are most likely to get a theoretical distribution that is it may not fit properly your data.
Okay, thank you, Prof. Samu.
Okay, we go through the last section. Non-Bayes distribution. The fitting can work with other non-Bayes distribution. The same way can be followed, but we need to define our own functions, or let's say our own distribution function, the theoretical one. You have a distribution function. In order to define this distribution function, now you need to define three functions, the one called DPQ. DPQ function, D the density function, P the CDF, and the Q the quantile function. You need to implement these in R, and then you follow the same way as we have done before. For example, let's say I have a distribution function called Sammuh. This distribution function, in order to be a valid distribution in R, in order to use fit distribution and these functions that I used in R, It must be a valid distribution. How it makes it a valid distribution in R? You need to define 3 functions. The first function is D, the density. Here you write D سموح, whatever after D. You call it whatever you need. The first letter must be D function with the data, okay, and your parameters. Here I'm writing my own distribution with some of my colleagues. It is called the cubic transmuted power function distribution. A cubic transmuted power function distribution. This distribution has 3 parameters. It's not in R. It's a new distribution. It is published in 2019 by myself and other colleague. So I write the density function. This is the D function. And the other 2, the B function. The B function, you write here the CDF. Okay, here this is the CDF of your distribution function. You need to pass the quantile and the parameters. The third function is the Q function, the quantile function, which is the CDF minus P, and here you need to pass the probability P and the parameters. Once you define these 3 functions, you are ready to use the fit distribution plus, okay, or the fit distribution library, let's say. Here I write fit4 in order to compare the same data that we used before, that we have done with the exponential, gamma, and log normal. And now we have a new distribution, let's say سموح. We are assuming probably سموح is the best one. Let's so compare this distribution with the other one. So I write fit distribution, my data of between 2 parentheses, between 2 or double quotation سموح, the theoretical distribution. Here I get the estimate of our parameters A, B, C. Standard error here is not available due to maybe the non-convergence for the in order to estimate, you need to hear the Hessian matrix or the variance covariance matrix in order to obtain the standard error. Maybe there is some, maybe the matrix of the Hessian matrix not inverted or whatever. So it's not a big deal now. Let's calculate the AIC and BIC for our for the distribution, for my distribution, okay. And here the log normal, gamma, and exponential. Still, according to the AIC, the gamma distribution is the most suitable one. سموح is the worst here, okay? So the distribution is the worst. So KS KS.test of my data, P سموح, with these parameters, I get B value, which is very, very small. That means I reject H0. I reject that our data come from سموح distribution. Let's see the plots. This line or this curve for سموح distribution, which is, as you see, it is far away from the other proposals, and also other plots confirm these results. May I give you the chance to try to generate data from distribution? Estimate parameters, you write your own distribution. This is the last activity. I don't know the time, if the time allowed. If not, we may see if there are some questions. This is to sum up. In this workshop, we have briefly given an introduction to R, fitting distribution with R, how, if I have data, how to look for the most suitable distribution that fit my data, and then how to measure the quality of this fit, and finally how to define my own distribution, and if I have a new distribution which is not built in R, how to define it. You need mainly the 3 functions that I mentioned, the D with P and the Q functions. That's all for my presentation, and if you have any questions, please, we can discuss.
Okay, all participants, someone? Yes, we have a question from Samu. If after fitting the distribution of our data, it turns out that our data, for example, follows a geometric distribution, can we say that our data also follow the properties of a geometric distribution?
Okay, what you mean by properties, if you mean the mathematical properties.
Maybe Ms. Amalia Hamadana can speak about the meaning of your properties. Maybe the characteristic, Prof. Samu. The characteristic, Prof. Oh yeah. Okay. Oh sorry, the connection still stop for Prof. Samu. We wait the Prof. Samu come back again from this webinar. Okay, thank you, Ms. Rahmadana. Maybe another participant will write the question before before Prof. Samu come back from this webinar. You can write in the chat box, or you can say you can speak on your Zoom. Okay, all participants, we remind again about the present absent of the webinar. You can click in the chat box bit.ly attendance 3 SBRC series 3. Welcome back, Prof. Samu.
Sorry, Dr. Ahmed, I'm back.
No problem, Prof.
We have internet. Okay, I'm not sure if the last question was once we fit our distribution to. Can you hear me very well?
Yes, we can hear you very well.
I said if she means that in her question, the properties, the mathematical and statistical properties of the distribution. Yes, the answer is yes. That means the moments, all the moments are correct, and all the skewness, cortis, and so on.
Okay, good. Thank you, Prof. Samu. Are the answer clearly covered your question, Ms. Ramadana?
If the results of the goodness of fit of my data are as follows, then which distribution should I choose which represent my data?
Like someone participants private message to me, Prof. The data is like here. Maybe I can share.
Okay.
This is the data. The question, if the result of the goodness of fit like this picture, then what's the distribution shall I choose which represent my data?
Okay. In fact, in order to look for what is the best distribution that fits your data, you need the raw data. The raw data must be given.
Yes. Pardon,
Yeah.
can you repeat again?
Here, okay. I said in order to look for the best distribution that fit your data, you need to have the raw data. The raw data. May I understand from this slide that you shared is you already have done the fitted, and here you fail to reject for the geometric distribution, reject for the discrete uniform, reject for the negative binomial. Okay, so what is the okay, here we can see that the geometric distribution is the one that fit your data.
Okay, so the fit is the geometric distribution, Prof.
But I'm not sure why we have here two alpha value. Let's say two parts of alpha value. You have 5%, 5%, 2%, 1%, and then another time 5%. Or okay, you are under Kolmogorov and yeah, I understand. Yes. By the way, it's not necessarily to get exactly the same results from both tests. Here you are applying Kolmogorov, and under Son-Darling you get at 5% you get fail to reject.
Yes.
Under Kolmogorov, but under Son-Darling you get reject. Yes, of course, it's not necessarily to get the same. And here we are not saying like pass or fail. There is a and you need to play with your alpha values.
Okay. So we can conclude that the geometric distribution is fit from this data, Prof?
Yeah, yes, exactly.
Okay, thank you very much, Prof. Okay, anyone to ask again?
Ahmed, if you share it again, how it is rejected at 5% but not rejected at 1%? This is not correct, I think. How here you see the test is rejected? I think there is something there is a mistake here. How it is rejected at 5% but rejected at 2% and 1%? If it is rejected at high value of alpha, it must be rejected at a lower value of alpha. Sorry. No. I'm mistaken. No. Wait. Rejected at 5%, but not rejected. Yeah, it's correct. So I mistake. Yeah, it's correct.
Okay. Thank you, Prof. Okay. Anyone again to ask the question from the session. It's very attractive material from me, but because the first step to we predict the model is we must know the distribution of the data. Okay, nobody else. Okay, if there is no, again, the question, we have the little appreciation for you, Prof. This the certificate like this. Maybe we will send the certificate immediately. We will show your certificate, Prof.
Thank you very much.
Thank you very much, Prof. Samu. And now we have to the last session from this meeting. I'm Ahmad Fauzian. I'm very sorry if many mistakes from attendance you, Prof. Samu. And then we can back to the MC. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Ahmad Fauzan, SPD MSI, and thank you, Prof. Monjat Samuh, PhD. It's such a great opportunity to have you with us. We hope we can do more collaboration in the future. Again, thank you very much.
Thank you very much, inshallah.
Well, ladies and gentlemen, now we come to the end of this SBRC webinar series 2020. On behalf of the host and the committee, we would like to extend once again our deepest appreciation to all speakers and to all participants for your support in this event. Once again, thank you and good afternoon. I'm Dia Dwi Maharani. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Prof. Samu. Okay, see you again another time.
It's nice to see you again, and hope Corona will end soon and we meet in such conferences again, and
yeah, also
to conduct more workshop face to face.
Oh, okay.
So, thanks for you and for the organizer, for all of you.
Thank you also for all participants. We will hope that in the future we will meet again. And also for some of my colleagues, Professor Bharti from Bangalore, India, Professor Hanan Said, and Bu Hasi, Bu Umu, Pa Fendri, and so on. I couldn't mention one by one in here. Especially for the head department of statistics, which is Prof. Edi Widodo. He also has been here for a while. So thank you very much, everyone. Bye. Ditutup.
Thank you.
Thank you, Ina. Okay, thank you very much.
Thank you again, and Assalamu alaikum.
Okay, bye-bye. Assalamualaikum.